Hello, welcome. How do we solve this? We have x to the power of x all equal to x to the power of 3. What is the value of x that will satisfy this challenge here? Yeah, if you look at this, you discover that we have to solve for 3 roots to this math challenge here. Now, we can easily say by this base and this base being the same, we can equate the exponent. In other words, we're going to have x equal to 3, which is one of the 3 roots from this challenge here. But how do we get the other 2 roots for this challenge? So let's take our solution here. All right, so we can solve this using 2 different approaches or 2 methods. Okay, we can either move this to this side of the equation, then we factor out x to the power of x or x to the power of 3. Okay, or we can log both sides of the equation. Okay, so let's take the log of both sides of the equation. Okay, so or better still, let's move this to this side so that this gives us 0. So this is going to give us x to the power of x and minus our x to the power of 3. This is equal to 0. Okay, now we are having x as the base here and we're having x as the base here. Okay, so what we want to do here now is this. We want to factor x to the power of 3 from both sides of this equation. So this is going to give us x to the power of 3 brackets. If we use this to divide this, let's quickly do it here. We're going to have x to the power of x dividing our x to the power of 3. What happened? Because the bases are the same, we apply the law of indices, which says that if you have your a to the power of your m all over a to the power of your n, this is equal to your a to the power of your m minus n. So if we do that, we're going to have this to be our x to the power of our x minus 3. So this side of it is going to give us x to the power of our x minus 3. Then minus, if we use this to divide this, it's going to give us 1. So we have here 1 equal to 0. Easy, right? Good. So at this point, what we do here now, if you look at this carefully, we are having this to the power of 3 times everything here equal to 0. So we apply the rule which says that if you have your a times your b equal to 0, it simply means that your a is equal to 0 or your b is equal to 0. So if we do that, it's going to give us our case 1. So our case 1, we're going to have our s to the power of 3 is equal to 0. Okay, so we take the cube root of both sides, and the cube root of 0 will give us what? 0. So we have x equal to 0 as one of the roots of this challenge here now. Now let's look at it from this perspective here now. If we have x to the power of 0, 0 to the power of 0 is undefined. Then here we have x to the power of 3. So we're going to have 0 to the power of 3 will give us 0. So if we have this to be undefined and this is equal to 0, so this root is rejected. Okay, so from here we can say this root is rejected. This root is rejected. Now let's take case 2. So we have here our case 2. Our case 2 says here we're going to have our s to the power of x minus our 3 minus 1 equal to 0. So let's continue on this side of it and see what this gives us. Move this to this side. We're going to have x to the power of our x minus our 3. This is equal to positive 1. Right? Good. So what do we do at this point in time? Again, here we can write x to the power of 0 here. Okay? So if we write x to the power of 0, then the basis will be the same. Then we can equate the exponents. Right? Good. But what we want to do here is easy. We want to log both sides of the equation. So if you take log of both sides, we'll have here log our s to the power of x minus 3. This is equal to the log of 1. This is base 10. This is base 10. So we have the power rule here of logarithm. It says that if you have log your a then to the power of your p, we move this back here to give us here our p times our log our a. So if we apply this rule, we're going to move the whole of this backward here. So this is going to give us our x minus 3 close bracket times our log x, this x equal to our log 1, this 10. Easy. Wow. Now, with what we have here now, what is log 1 base 10? It's 0. Okay, so we now have this to be our x minus 3 close bracket times log x base 10. This is equal to 0. Again, we apply our zero product rule. So from here, look at our zero product rule. Okay, from here, we can equate this to 0, equate this to 0. So this is going to give us here our case. Let's take case 2 of star. Okay, so we have here our x minus 3 is equal to 0. So we have our x is equal to our positive 3. So this is our x2. Meanwhile, we've calculated for our x1 here already. So our x2 is equal to 3. So here we're going to have here, if we substitute, this is going to give us 3 to the power of 3. And if we put in 3 here, this is going to give us 3 to the power of 3. So this is accepted. Okay, so if this is accepted, let's take this other side. So we have case 2 of star star. So we take this here to give us our log. We have log x is 10 equal to 0. So how do we get the value of x from here? Now, there is a strong relationship between indices and logarithm. Or better still, we can rewrite this in another format. Okay, so what is that format? We know that 0 could be written as log 1 base 10. Okay, so from here, we can write this as our log x base 10. This is equal to our log 1 base 10. Look at this. So we have log base 10, log base 10. So what happened? This leaves the system. So we're going to have x is equal to 1. So x equal to 1 is another root. Now this is our x3. So let's see if this satisfies the original equation. So we have here 1 to the power of 1 will give us 1. 1 to the power of 3 will give us 1. So this is also accepted. Okay? So this is also accepted. Now we have 3 roots as the question demands. And we discovered that 2 of them will satisfy the original equation. So, but from here, can we still get another root, a 4th root to this challenge? Yes, minus 1 could also satisfy this equation. If I put in minus 1 here raised to minus 1, that is going to give us 1 all over minus 1 raised to 1, which is 1 all over minus 1, which is same thing as minus 1 on the left hand side. And on this other side, minus 1 to the power of 3 is going to give us minus 1. So the minus 1 satisfies this equation also. In other words, minus 1 is another accepted root to this challenge. So we can equally say, though this is not from the procedure, but from guess, we have x4. x4 is equal to minus 1. It's also a root to this challenge and it's also accepted. So we said this is rejected and this is accepted, this is accepted, this is accepted. So this brings us to the end of this smart class. Thank you for being there. See you in our next class.